Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Adriana binti Khalid. So I am going to explain about how I did my calculation for the case study. So firstly, I read the question. After I read the question, I take out all the informations given, which are the cross-sectional area, the value of temperature, the value of pressure, the value of K prime YA, and the value of K prime XA. Then I draw the back absorption column diagram, which is the 2D diagram, and I write down all the informations given. The informations given are V1, which is 13.65 kg mole per hour, Y1, which is 0.026, Y2, which is 0.005, V2 is not given, the value of L2, which is 45.36 kg mole per hour, and the value of X2, which is 0 because this is a pure solvent. So the value of L1 is equal to the value of L2 because it is a dilute solution, which means liquid flows in equals to liquid flows out. For graph plotting, first we need to plot the equilibrium line. Using the equation YA equals to mxa to find the two coordinates to plot. So the value of equilibrium gradient, which is m, is already given, which is 1.186. So just substitute the value of m into the equation. So these are the points that we obtain from the linear relation. So we use these points to plot the equilibrium line. So from the graph I did, which is the y against x graph, this is the equilibrium line. I plot using the points. Next, I need to plot the operating line. So first, I need to find the value of x1 using material balance. So using the equation, I insert the value that already have and make x1 as the subject. So the value of x1 is 6.4789 times 10 to the power of negative 3. So here I got 2 points to plot the operating line, which are point 1 and point 2. So for point 1, I got the value of x1 is 0.006479 and the value of y1 is 0.026. For point 2, the value of x2 is 0, the value of y2 is 0.005. So from these 2 points, I can plot the operating line in the graph. So this is what I did. I first plot the P1 value, P1 point to P2 point. So this is my operating. Then to find the value of PM1, I use the slope equation and I substitute all the values. So I get negative 1.60. So next, I use the linear equation and substitute the value of the slope, which is m, into the linear equation, and I get the y-intercept. So after I get all the informations, I plot the line. So from the graph, I first plot the y-intercept, which is 0.0364, and then I connect it with the P1, and using the same gradient, I plot all the way to the equilibrium line. So the intersection between the line with the equilibrium line from the P1 to equilibrium, PM1 to equilibrium line. So this will be my y(I1) and my x(I1). So these are the values. These are the values from the graph that I obtained. So for the second trial, I need to use this original slope equation, but first I need to know the value of 1 minus xim and 1 minus yim. So using this equation, I can get the value of y minus yim, which is 0.979, and the value of 1 minus xim is 0.9901. Then using the original equation, I substitute the value that I get, and I get the value of PM1 is negative 1.61. So the value of PM1 on the first trial and the value of PM1 on the second trial is the same, which is negative 1.6, so the slope is accurate. Next, to obtain the value of PM2, so I substitute the value of PM1 into the linear equation, so I get the y-intercept, which is 0.005. So to get another new point to plot, so I substitute the value of y equals to 0 into the linear equation, so I get the value of x is equals to 0.003. So that is my new point. So these points I will plot into the graph. So from the graph, from the point P2, I plot up until the new point that I obtained just now. So the intersection between the PM2 line with the equilibrium line, I can obtain the value of yi2 and xi2. So these are the values that I obtained from the graph. Since I already have the values, so I can find the value for xi minus xm and also y minus yim, which is 0.006. And I can also get the value of V1, V2 and V average since I already have all the values. And I also divide them with 3600 to get the unit of kg mole per second, and also for the value of L1, L2, L average and L prime, I also divide it by 3600 to get the unit of kg mole per second. Then I substitute all the values into this equation, V average minus V average over S, y1 minus y2 equals to k prime ye z y minus yim. So z represents the height, so I make z as the subject, so I got the height is 1.946 meter. For question B, calculate tower height using k prime xa. So I need to use this equation, L average over S. So first, I need to know the value of xi minus xm because it is not given. So first, using this equation, I got the value of xi minus xm is 0.003. So substitute into the equation, I get the value of height is 1.964 meter. Question C, calculate tower height using k capital prime ya. So I need to use this equation, but the value of capital K prime ye is not given, so I need to find first. But I also don't know the value of 1 minus ym, so I need to find it first using this equation, and I got the value of 1 minus ym is equal to 0.983. Then I can substitute the value of 1 minus ym into this equation to find the value of capital K prime ya. And after I got the value of capital K prime ya, I can substitute into this equation. But before that, I also need to find the value of y minus y star m. So I substitute into this equation and make z as the subject, and I got the value of z is equal to 1.934 meter.